Hello everyone. In this class, we'll discuss some more examples on unit step function, and this is the last class on unit step function. Here we have two examples, and both the two are the most important examples. You have to practice both the examples. First is express the function f of t is equal to pi minus t when t lies between 0 and pi, means 0 is less than t less than or equal to pi, sin t when t is greater than pi, in terms of unit step function, and hence find its Laplace transform. You have to express this given function in terms of unit step function. After that we have to find the Laplace transform. Here the given function, this is the discontinuous function, and the given function having two sub functions, so that we have to use the third property of unit step function. That is, we know that if f of t is equal to f1 of t when t is less than or equal to a, f2 of t when t is greater than a, then f of t is equal to f1 of t plus of f2 of t minus f1 of t into u of t minus a. Therefore, f of t is equal to pi minus t, because f1 of t is pi minus t, f2 of t is sin t minus f1 of t is again pi minus t into u of t minus a. See, this second function, this term gives the unit step functions, means heavy side function, so that the given function is expressed in terms of unit step function is over. Next we have to find the Laplace transform. For that, first we have to find the Laplace transform for this unit step function, so that Laplace transform of f of t is equal to Laplace transform of this pi minus t plus Laplace transform of this unit step function. Now to find this one, I have to take f capital F, so that we will avoid the confusion between f's, so that I am taking capital F here, and here value of a is pi. F of t minus pi is equal to sin t minus pi plus t, because f of t minus a value is f sin t minus pi plus t. Then f of t is equal to sin of t plus pi. Change here t to t plus pi, otherwise add here pi, we get sin t plus pi minus pi plus t plus pi as it is, so that we can change t as a t plus pi. Plus pi minus pi get cancelled, remaining is sin t plus pi is, means sin theta plus pi is minus sin theta, therefore it is minus sin t plus t as it is. And find Laplace transform for this one. We get L of f of t is equal to f bar of s, which is equal to minus 1 divided, minus as it is, Laplace transform of sin t is 1 divided by s square plus 1, plus Laplace transform of t is 1 factorial divided by s square. 1 factorial means again it is 1, therefore 1 divided by s square. Now also Laplace transform of f of t minus pi into u of t minus pi is equal to e raised to minus pi into s into f bar of s. We know that f bar of s is 1 divided minus 1 divided by s square plus 1 plus 1 divided by s square. Therefore, Laplace transform of sin t minus pi plus t into u of t minus pi is e raised to minus pi s into 1 divided by s square. So, because I am taking positive term first, after that negative term, so that e raised to minus pi s into 1 divided by s square minus 1 divided by s square plus 1. Name this is equation 2 and this is equation 1. Now substituting equation 2 in equation 1, we get Laplace transform of f of t is equal to Laplace transform of pi minus t plus Laplace transform of that given function is e raised to, unit step function is e raised to minus pi s into 1 divided by s square minus 1 divided by s square plus 1. So that here Laplace transform of pi is constant, so that Laplace transform of constant is 1 by s, therefore it is pi by s minus Laplace transform of t is 1 divided by s square plus e raised to minus pi s into Here take LCM and simplify. We get s square plus 1 minus s square divided by s square into s square plus 1 plus s square minus s square will cancel. Remaining is 1 divided by s square into s square plus 1. Therefore multiplying this term to this one, we get e raised to minus pi s divided by s square plus s square into s square plus 1. Therefore the required Laplace transform for the given function is Laplace transform of f of t, which is equal to pi by s minus 1 divided by s square plus e raised to minus pi s divided by s square into s square plus 1. Next example, using the unit step function, find the Laplace transform of the f of t is equal to sin t when 0 is less than or equal to t is less than or equal t is less than pi, sin 2t when t is less than pi is less than or equal to t is less than 2 pi, sin 3t when t is greater than or equal to 2 pi. Here we have the given function having a 3 sub function, so that we can use the fourth property of unit step function. You already know what is the fourth property. Say, from using the fourth property of unit step function, our f of t will be f of t is equal to sin t plus sin 2t minus sin t into u of t minus pi plus sin 3t minus sin 2t into u of t minus pi. For the first, we have the value of a is pi. For the second term, value of a is 2 pi. Then Laplace transform of this one is Laplace transform of f of t is equal to Laplace transform of this sin t, then Laplace transform of this unit step function plus Laplace transform of this unit step function. Now to find this Laplace transform of this whole f of t, first we have to find this Laplace transform of these two unit step function. Name this unit function, name sin 2t minus sin t as f of t minus pi, because a value is pi here, capital F of t minus pi, and for this one where I am taking f g of t minus 2 pi, because a value is 2 pi here. So that Laplace transform of sin 2t minus sin t into u of t minus pi, let f of t minus pi is equal to sin 2t minus sin t. Then f of t, change t to t plus pi or add this to pi, we get f of t is equal to 2t into t plus pi, because t changes to t plus pi, minus sin t plus pi. It will be sin 2t plus 2 pi minus sin t plus pi. We know that sin theta plus 2 pi is sin theta, then sin theta plus pi is minus sin theta. So here I am writing that one, minus into minus plus, therefore f of t will be sin 2t plus sin t. Now Laplace transform of f of t is equal to f bar of s, which is equal to Laplace transform of sin 2t is 2 divided by s square plus 4 plus Laplace transform of sin t is 1 divided by s square plus 1. Also Laplace transform of f of t plus pi into u of t plus pi is equal to e raised to minus pi s, because a value is pi here, therefore it is e raised to minus pi s into f bar of s. We know that f bar of s is 2 by s square plus 4 plus 7 divided by s square plus 1. Therefore Laplace transform of sin 2t minus sin t into u of t minus pi is equal to e raised to minus pi s into 2 by 4 s square plus 4 plus 1 divided by s square plus 1. Name this is equation 2. After that take the last term, that is Laplace transform of sin 3t minus sin 2t into u of t minus pi, you have to find. Now name this as g of t minus 2 pi is equal to sin 3t minus sin 2t. Then change this t to t plus 2 pi, or here add to 2 pi, we get g of t is equal to sin 3 into t plus 2 pi minus sin 2 into t plus 2 pi. Simplify this one, we get sin 3t plus 6 pi minus sin 2t plus 4 pi. We know that sin theta plus even pi is as it is, means sin theta sin 3t minus sin 2t, because sin theta plus 4 pi is sin theta, Sin theta plus 6 pi is also sin theta, so that sin 3t minus sin 6t. G of t is equal to sin 3t minus sin 2t. Also, we know that Laplace transform of g of t is equal to f bar of s, which is g bar of s, which is equal to Laplace transform of 3t is sin 3t is 3 divided by s square plus 9 minus Laplace transform of sin 2t is 2 divided by s square plus 4. Now, to find the Laplace transform of this one, we have to use the second property, that is also Laplace transform of g of t minus 2 pi into u of t minus pi is equal to e raised to minus 2 pi s into g bar of s. We know that g bar of s is 3 divided by s square plus 9 minus 2 divided by s square plus 4. Therefore, Laplace transform of sin 3t minus sin 2t into u of t minus pi is equal to e raised to minus 2 pi s into 3 divided by s square plus 9 minus 2 divided by s square plus 4. Name this is equation 3. So now substitute 3 and 2 in equation 1. We get Laplace transform of f of t is equal to 1 divided by s square plus 1 plus e raised to minus pi s into 2 divided by s square plus 4 plus 1 divided by s square plus 1 plus e raised to minus 2 pi s into 3 divided by s square plus 9 minus 2 divided, this is 3 divided by s square plus 9 minus 2 divided by s square plus 4. This is the required Laplace transform of given f of t, then when f of t having a 3 sub-functions. Here we have homework here. Express the following function in terms of unit step function and hence find the Laplace transform. The given function is f of t is equal to t square when 0 is less than t is less than or equal to 2, 40 when t is greater than 2. You have to try this one. For this, your unit step function topic is over. Here we are solving simple functions using the second property and also solving the discontinuous function when f of t having the two sub functions. Use the third property, write f of t as similar as given property given, and also for use fourth property when f of t having 3 sub functions, and use standard f of t from the fourth property to write the f of t for the given example. After that you get 1 or 2 unit step function terms in your f of t. You have to solve separate. If the given function having 3 sub function, you get 2 unit step function, so that you can solve both of the unit step functions separately and substitute those values in f of t. You will get the required answer. Then if the given function is having 2 sub function, you will get only 1 unit step function in that f of t. First you have to solve that f of t, you have to solve that unit step function and substitute that in f of t and find the Laplace transform. For that you will get the required result. In this way you have to solve all the examples belongs to unit step function. If you have any doubt, contact me. Otherwise you have to write in one page separately, then we will discuss in online class. Here we have 2 similar examples. See here also f of t is equal to sin t, sin 2t, sin 3t. Here limits are different and here limits are different. I am solving one of them. You have to solve the another one. Similarly, here I am giving one homework example, that is the given function having 2 sub functions. Terms are t square 40 and here also t square 40, and here is limits is 1 is less than or equal to t less than or equal to 2, and here t is greater than 2. For this one, t lies between 0 and 2, means 0 is less than, t is less than or equal to 2 and t is greater than 2. You have to solve both the examples. Start. starting only I have given first assignment, that is you have to write all the trigonometric functions and integral formulas, trigonometric formulas, differentiation formulas. That is first assignment, and today I will send the second assignment. You people have to write both the assignments, and I will tell you the last date of submission. You have to send before that date or on that date. Okay.